We already discussed some problems and also some solutions in the roundtables yesterday. So now, to make it more like a webinar, I have some background information first and then afterwards some solutions. So let's start. As you already know, so the pigs have a very low sweating capacity, so related to high ambient temperature or elevated temperature, and that is mainly based because of the types and the amount of sweat glands pigs have. And in addition, pigs also have a relatively small lung volume, reducing also the capacity to lose heat via panting. And characteristically, pigs also carry a very thick subcutaneous fat layer, which also impedes heat loss over the skin. So taken all together, pigs have a very limited ability to dissipate heat into the environment, which may lead to heat stress, especially at the combination of a high ambient temperature and relatively high humidity level. But also larger pigs, like sows, are much more vulnerable to heat stress due to their large body size and also their body surface to body weight ratio. And they also have a higher energy intake and also a higher subcutaneous fat tissue. And also genetic selection tends to be one reason why they are more vulnerable to heat stress. You already know this figure, which was mentioned by Mette, and also Hermann mentioned this figure. So I don't want to be here on this slide for a very long time, but what I wanted to give you here is also the thresholds which were mentioned by Mette before for the transport of the animals, so that there are different thresholds for the TCZ, the thermal comfort zone for sows, which are lower than for the finishing pigs, and for weaners the upper threshold for the thermal comfort zone is around 25 degrees Celsius. So if you would like, you can look up these thresholds again. So I have to hurry a little bit that we can get the time back we lost before. So I will go on. So as you already heard from Hermann, heat transmission is done by 4 mechanisms. First, radiation, so that is the heat is lost via electromagnetic waves to a cooler object. Then the conduction, that is between 2 solid objects. So when a pig is lying on the floor, that is conduction. Then we have the convection, this is through the movement of a gas or a liquid. And then we have the evaporation, what we all know by sweating, and this is the conversion of water from the liquid to the gas phase. So when the pigs are in the thermal comfort zone or thermoneutral zone, evaporation is kept to a minimum. So we have pictures like these on the trucks. But whether we have or when the pig is challenged with higher ambient temperatures, pigs increase the evaporative heat loss through the skin and also through the respiratory tract. And then we see these animal-based measures like panting behavior on the trucks. So what we all have to keep in mind is that heat transfer at high ambient temperatures via conduction, convection and radiation are less effective due to a low thermal gradient between skin and air temperature. And a high relative humidity also negatively impacts the rate of evaporative heat loss through the skin and the respiratory tract. So all these 4 mechanisms are affected by the combination of high ambient temperature and relative humidity levels. So, and also I would like to mention here the definition of heat stress, which is mentioned by the EFSA, and the definition from the EFSA differs to some extent from formally definitions. So the definition proposed by EFSA is, or EURCAW defines heat stress as a situation where an animal experiences heat stress and or negative affective states such as discomfort and or distress when exposed to a high effective temperature. So consequently, to fully prevent pigs from heat or cold stress during their journeys, we should transport them in their TC set. But we already identified yesterday in the roundtables that this is not possible. So it's really a huge problem we have to figure out and how to deal with this. So yes, and then stress or negative affective states start when the pig is no longer in the TC set. That is also one thing we talked about, because sometimes we are not so sure about if we could see heat stress when the pig is no longer in the TC set, because this is the fact when the temperature is around 25 degrees. And do pigs show signs of panting behavior at this low temperature of 25 degrees? So can we perceive that the pig is stressed by heat stress? So that is a question we discussed yesterday in the roundtables, and I think that's a very good point to think about this. Yeah, and so I think the other bullet points here, you know about this. But I would like to mention here our QR codes, which you can also find on the fact sheets we published on our website. So if you would like, you can scan the QR code, and then you can see some short video clips from pigs showing panting and pumping behavior or attempts to lie laterally on the truck. And what we all also know, or probably you all know, is that on a truck the temperature or the microclimatic conditions are not the same at the different locations. So they differ depending on the location on the truck. So the highest temperatures can be found mainly in the front area and on the lower deck, and also in the middle of the vehicle, not on the lateral sides, but in the middle. So it's important, if we want to assess these animal-based measures as an inspector, we should look at the location where the extreme temperatures are located. So we have to know where to look at. So we don't have to look at each location, because that takes a long time. So it's better to think about looking preferably at the location with the highest temperatures. And while the vehicle is stationary, the highest temperature occur at this location here on the upper deck. And when the vehicle is driving, the highest temperatures are more widely distributed over different parts of the vehicle. And then also I would like to mention the highest humidity levels. So as we all know, the combination of relative humidity and the ambient temperature is considered to be the decisive stress factor for thermoregulation of the animals. So, and it was discovered in one study that the highest amounts of humidity levels are found on the upper deck. So, and then, as we all know, when the vehicle is driving, some fresh air is coming in, mostly from the rear, and then go to the front of the vehicle, flushing through the vehicle, but that's not the problem. The problem is when the vehicle is stationary. So on this slide you can see it's very impressive, I think. So when the vehicle is standing and not moving, the temperature rises up, and especially on the upper deck. That's the blue line. And then the temperature rises, and when the vehicle is driving again, it's lowered, and then when the vehicle is stationary again, it rises again. So it's an up and down, and also through the loading and unloading phases there, the heat stress is the most impressive, or is stress, yeah. So, and then taken all together, the temperature, the ventilation, and the humidity levels, then we have some locations where to look at, and that is what I want to focus on the slide to make it a little bit shorter. So during hot weather and high relative humidity levels, inspectors should look for visible signs of panting, pumping, and dog-style sitting, preferably there where the pigs are exposed to extreme temperatures, high or low temperatures. And these are these locations. I don't want to be on this slide for a long time, so we also heard a lot of space allowance and K values. So here I've put these 5 biological functions of space, where the EFSA gives some 4 different biological functions for standing posture, the ability to maintain stability on the moving vehicle, then resting in a normal semi-recumbent posture, and also the 4th is the room to thermoregulate. And here are the different K values which were proposed. Nobody knows if it's really the correct, but they're proposed. So, and also the vertical space. Mette mentioned that there's a gap for pigs. That was in her table. What we know from other studies, that there is some evidence that we know that when the height is less than 30 centimeters for a passively ventilated vehicle and 50 centimeters for a mechanically ventilated vehicle, above the highest point of the pig's body, then the temperature will rise. So that should be kept in mind maybe, but actually there's a lot of work to do, so some studies are missing in this special case. So then I would like to come to the preventive measures we could take to prevent pigs from heat stress, and already Pavel mentioned a lot yesterday, so I highlighted the one which I haven't heard from Pavel yesterday, and that is we should park the vehicle vertical to the wind direction, and that is what the picture should illustrate, that the air can flush through the vehicle. So that might be a new option, because the other ones may be already known. Then we could also try to allow pigs to have water ad libitum in the pre-transport phase, so that they don't suffer from dehydration. So, because sometimes the transport duration is very long and they have no water, or they are not familiar with the drinkers, or they can't reach the drinkers because the stocking density is so high. So we should give them ad libitum access to water in the pre-transport phase. And then the preventive measure we can take during the time of the transport. And there was a study on the sprinkling devices. So it might be possible to sprinkle or moisten the animals for 5 minutes before departure and before unloading. And the study revealed that there was a trend towards a greater reduction in gastrointestinal temperature by arrival when the pigs were sprinkled a little bit, but they will also less often at the drinkers than in the lavage. Maybe they are not so thirsty then, I don't know. And what they also observed, that there was no detrimental effect on the loading procedure. So this water sprinkling had no effect on slipping or falling behavior during loading and unloading. And what they also observed, that the pigs spent more time standing and less time lying throughout the transport, but that was also discovered or observed for pigs in the lavage when they were sprinkled. So maybe sprinkling encouraged them to be more active. Yeah, so as a conclusion, we can say that due to the enhanced air movement in the driving truck, with sprinkled pigs are likely experiencing greater evaporative heat loss capacity, which enables a better control of core body temperature under high ambient temperature. and if physiological heat dissipation, such as panting, becomes less effective. So it might be a possibility to sprinkle pigs before departure, so that the wind can flush and also enhance evaporative heat loss. And here I have some pictures, and I know this one was also mentioned yesterday by Pablo. That is the sprinkling device, or this is like powder, water powder. It's very tiny drops of water which can be sprinkled, and then there are some other measures which can be taken, like floor insulation or insulation on the sidewalls and the roof, and also drinking a water cooling system, because animals don't want to drink hot water. So it might be a good idea to have a cooling system for the water, and then that will encourage the pigs to drink. Then the next preventive measure, that is a management system which is used by Vion Food Group, and they kindly provided it for this talk. That is a system where the transporter and the driver of the trucks can see when there is a free or available capacity in the larage in the slaughterhouse. So they can schedule the transport a little bit better, so that the standing times at the abattoirs are not that long. So on this slide you can see a little bit better. So they see here's a free space, so they can arrive, and here's full, so they should keep driving. So don't stop at the abattoir, so keep driving. That might be a good possibility to omit this longer standing time. And also these are some examples I found on the website from Eyes on Animals. So for poultry, they tried to color the floor with white color, and they observed that it's not scientifically validated, but they observed that this lowered the temperature about 2 or 3 degrees Celsius. And then also, I think you all know, these mobile fans can be put near the trucks to make, so for the passively ventilated trucks, that there is some air movement around the pigs. Then another example which comes from Compacto, that's an abattoir in the Netherlands, and that was kindly provided yesterday from this guy here. He sent me some pictures. So that is the slaughterhouse from the outside, and then the truck is driving this way and gets in, and inside it looks like this. So there's a huge waiting hall, and it's covered and air conditioned. So the vehicles can wait for unloading while they are parking in this air conditioned zone. So it might be also a possibility for the trucks to be or to prevent pigs from heat stress during these waiting times. And here's the unloading area, and when they are ready with unloading, they go or here's when they are waiting, they are standing here, and it's fully ventilated and air conditioned. And here's the wash box, and when they finish washing, they go out this way again. So there's no waiting area outside, all is within this building. That is what I've prepared for you today, and maybe the pictures or these inspiring examples may encourage you to discuss if this is a solution, maybe. So yeah, thank you very much.